talk about the water-soluble vitamins. These are all the B vitamins and vitamin C. Our objectives for this chapter are to be able to describe the water-soluble vitamins and the differences between energy-yielding nutrients and the fat-soluble vitamins, which we will talk about in the next lecture. Identify the B vitamins and their roles in the body, food sources, and deficiency symptoms. Identify roles in the body, food sources, and deficiency symptoms of vitamin C. Identify risks and benefits of supplementation of the vitamins. So let's go ahead and get started. So we talked briefly about vitamins earlier on in the course, just giving a brief overview, but we're going to get more in depth with the vitamins now. Vitamins are essential to life, and as a reminder, they are organic, meaning they contain carbon. And vitamins are used to help regulate body processes and support growth in order to maintain life. They support our nutritional health, but they do not actually cure diseases. So a lot of times you might see marketing for supplements and different things saying that if you eat this vitamin, it'll cure something. But they actually don't cure diseases, but they can help support good nutrition. So there are some differences of the vitamins from the energy-yielding nutrients that we've already talked about so far, like the carbohydrates, proteins, and fats. And the first is the structure. So vitamins are individual units, and they're not linked together like, you know, how glucose and amino acids were different molecules linked all together. Vitamins are individual structures. The function, so energy-yielding nutrients are used for energy, whereas vitamins are not. We do not burn them for energy, but the vitamins can be used to help enzymes release energy. And remember, in the last one of the last lectures, we mentioned coenzymes. A lot of vitamins are coenzymes, which are the helpers to enzymes that help to release energy from carbohydrates, proteins, and fats. So we're not getting energy directly from vitamins, but they are helpful to improve the release of energy from carbohydrates, proteins, and fats. And then food contents, so in the carbohydrates, proteins, and fats, we measured everything in grams, but vitamins are much smaller, so the vitamins are measured in milligrams or micrograms or equivalents, but not in grams. So they are much smaller molecules. So when we're talking about the vitamins, we need to talk about bioavailability. And bioavailability is the rate at and the extent to which nutrients are absorbed. So basically it's saying how well do we absorb these nutrients and how fast do we absorb them. So factors that might influence bioavailability of vitamins would be the efficiency of digestion and the time in the GI tract. So we might have some vitamins that might be more easily digested or more efficiently digested than others. Our personal nutritional status is definitely a factor that can influence our ability to absorb nutrients and vitamins. The method of food preparation, so whether food is raw, cooked, or processed affects the vitamin content of those foods, and we will talk more about that as we go through the specific vitamins. The source of the nutrients, so if it's from an animal source, a plant source, or a supplemented or fortified food, that definitely affects the absorption and the way we absorb the vitamins. And then other foods consumed at the same time. So sometimes foods that we eat at the same time can affect the absorption of other foods or other vitamins. So for example, if we eat a plant source of iron, so something that's like a dark leafy greens like spinach or greens, those have a lot of iron in them, but we don't absorb the iron from plant sources as well as from animal sources. So something that we can do is we can eat a food that has vitamin C in it, and the vitamin C can help absorb the iron better from the plant source. Now, if we're an animal source of iron, we don't really need the vitamin C per se, but in a plant source, it's a different type of iron, so we definitely need to use that vitamin C to help it if we are able to do that. So if we eat those two foods at the same time, we can definitely make a difference in our absorption of the iron. So that is an example of that. And there are foods that can affect negatively the absorption of other nutrients. So certain vitamins or minerals fight for absorption. So if we have a lot of two different ones, there's only one that's going to win out. So that is something that is very important when we're talking about the ability to absorb our vitamins and minerals. So some vitamins are available from foods in the inactive form known as precursors or provitamins. And these are the inactive forms, like I mentioned, of the vitamins. And these can be then converted into the active form in the body. An example of this would be beta-carotene. So beta-carotene is the precursor or the provitamin for vitamin A. So when we eat beta-carotene, we can convert it into vitamin A once we ingest it. So to monitor intake, we must count the active and potential from inactive forms of certain vitamins. So that means that we would have to count, if we eat a lot of beta-carotene, that would count towards our vitamin A amount in our diet. The organic nature of vitamins is important because since it contains carbon, they can be destroyed by exposure to light, oxidation, cooking, and storage. And again, as we get into each vitamin, we'll talk more in depth about the ways that these can affect each vitamin. So in previous chapters, we talked about the hydrophilic and hydrophobic molecules, and vitamins, some of them are hydrophilic and some of them are hydrophobic, which affects their solubility or the ability to be dissolved in water. So this affects absorption, transport, and excretion. So the water-soluble vitamins, they are the hydrophilic, which means they like water, and these would be the B vitamins and vitamin C. And because they're water soluble, they move directly into the blood and they can travel freely once they're in the blood. So they're very free to move about. The fat-soluble vitamins are hydrophobic, meaning they don't like water. And these are vitamins A, D, E, and K. And then these vitamins cannot go directly into the bloodstream. They have to go into the lymph system and then into the blood. And they need transport proteins to move around. So they don't move as freely as the water-soluble vitamins do. And usually those fat-soluble vitamins, if we get a lot of extra of them, they are held in fatty tissues and in the liver until they are needed by our bodies for other processes. So that being said, water-soluble vitamins must be eaten more regularly because we do not hold on to them for very long. So if we get extra amount of vitamin C or one of the B vitamins, usually we will just pee it out and it won't accumulate in our body. But if we get a really high amount of any of the fat-soluble vitamins, they will be stored and it can negatively affect our health. But we also don't have to eat them as often because we are able to store them a little more. So what's interesting about vitamins is that the inadequate intake and excessive intake of vitamins can both cause problems. So a toxicity, meaning too much of the vitamins, can definitely occur. And there is a theory about vitamins, I think, that sometimes people have, that they think the more the better. I need a lot of vitamins because they're healthy, but more is not necessarily better because we can have toxic amounts of these vitamins in our bodies. So for excessive intakes, they have set recommendations called an upper limit, or UL, and it defines the highest amount of a nutrient that is likely to not cause harm, for most healthy people when consumed daily. So they've done a lot of research and figured out that if you eat up to this upper limit, you should not have any problems or health complications from doing that. The risk for harm increases as the intakes above the upper limit increase. So the more you eat above that upper limit, the more at risk you are for having potential harm to your health. So upper limits are set for niacin, vitamin B6, folate, choline, and vitamin C. Those are all the water-soluble vitamins that have upper limits. And the other vitamins don't have upper limits because there's not enough research to show or they haven't found a toxic level of them yet that would cause any problems, because like I said earlier, water-soluble vitamins, usually if you get too much, you can pee them out. So there have been upper limits set for some of them though, because they did find that too much of some of these listed here can cause harm. It is difficult to get excessive amounts of vitamins from food. So if you eat something, say, that's got a lot of vitamin C and you eat a ton of oranges, that's not necessarily going to give you an excessive amount of vitamin C. But it's much easier to exceed that upper limit through supplementation. So we're going to talk a whole lot at the end of the lecture about supplementation. But knowing that eating food that have a lot of these vitamins in them is not necessarily going to make you at risk for getting too much of these.